Hey everyone, in this section, you'll learn an important concept in client-side JavaScript and Node, how variables and functions are scoped, and why modularity is essential. When we run JavaScript inside a browser, any variable or function we declare is added to the global scope. For example, if we define a function called sayHello, it becomes part of the global scope and is accessible via the window object. However, there's a problem with this behavior. In real-world applications, we often split JavaScript code into multiple files. If we define a function named sayHello in two different files, the second definition will override the first one, leading to unexpected behavior. To build reliable and maintainable applications, we should avoid defining variables and functions in the global scope. Instead, we need modularity. This means breaking our code into small, self-contained modules where variables and functions are encapsulated, preventing unintended conflicts. In Node, every file in an application is considered a module. The variables and functions defined in a module are scoped only to that file. In object-oriented programming terms, they are private. They're not accessible outside the module unless explicitly exported. Every Node application has at least one file or module, which we call the main module. For example, in our case, app.js is the main module. Let me demonstrate this. If we delete all the existing code in app.js and add console.log module. Now, if we run the script in the terminal using node app.js, we get a JSON object with key value pairs. It includes properties like ID, exports, parent, file name, which is the complete path to the file, loaded, children, and paths. At first glance, you might think the module object is global, like console, but it's not. It only appears to be global, and we'll soon see why. The key takeaway from this lesson is, every file in a Node application is a module. Variables and functions inside a module are private by default. To use a variable or function outside a module, we must explicitly export it. Let's add a new module to this application. I'm going to create a new file, logger.js. Imagine we're building a module for logging messages, something we can reuse in various parts of this application or even in other applications. So, logger.js now. In this module, let's say we want to use a remote logging service to store our logs. There are websites that offer logging as a service. They provide a URL and we can send HTTP requests to log messages in the cloud. Let's declare a variable, URL, and assign it a value like this. Now, of course, I'm making this up. This might not be a real service. But for the sake of this example, let's imagine this is the endpoint where we send our log data. Next, we need a function called log that takes a message. In this function, we'll send an HTTP request to log the message. But to keep things simple and focus on modularity, we'll just log the message to the console for now. Both the URL variable and the log function are private to this module. They're not accessible from outside. But in our app.js file, which is our main module, we need to use this logger module. So how do we make the log function accessible from outside? We use the module.exports object. This means the object we're exporting has a single method called log that references our function. Now, if we wanted to export the URL as well, we could do something like this. However, in real-world applications, we usually only export the essentials. This URL is just an implementation detail. We don't need to expose it. Think of it like a keyboard. A keyboard has buttons on the outside. That's what we interact with. But inside, there's a complex system we don't need to understand. It can change from one model to another, but the public interface stays the same. So, in our logger module, the URL is like the internal components of the keyboard. We don't need to export it. Instead, we just expose the log function. Now, we're done with our logger module. The next step is to import or load this module and use it in app.js. We use the require function to load a module. This function takes one argument, the name or path of the target module. Unlike browsers where we don't have the require function, in Node.js this is a fundamental feature. So let's say we want to load the logger module. Since both our app.js and logger.js files are in the same folder, we use / to indicate the current folder followed by the module name, something like this. Notice that we don't need to add .js at the end because Node automatically assumes it's a JavaScript file. If the module were in a subfolder, we'd specify that folder in the path like this: const logger require subfolder /logger, or if it were in the parent folder, we'd use .. to move up one level like this. The require function returns the object that the target module exports. Let me show you. We'll store the result in a variable. Here the variable is logger. Let's console it using console.log. When we run this, we'll see an object that contains a single method called log. That means we can call it like this. A best practice when using require is to store the returned object in a const rather than let or var. This prevents accidental reassignment. If we accidentally do this, logger equals 1, we'll get an error when trying to call logger.log. With const, we get a clear error message at compile time rather than a confusing runtime bug. With this approach, in app.js, we no longer import an object, we import a function. So we can call it directly like this. And that's it. Now you know how to use modules in Node.js with require, how to properly structure your imports, and best practices for avoiding common mistakes. Thank you for watching this tutorial. If you enjoyed it, please like and subscribe. See you in the next video.